Okay, this lesson is on solving exponential equations, so we're looking at lesson 2. We're going to look at some more techniques for solving exponential equations. These questions might be a little bit more challenging, some of them anyway, but you will learn some new techniques for solving exponential equations in this lesson. Okay, so for the warm-up, it asks us to just simplify, so it's just reviewing some of the concepts that you should know from before, but maybe in a new type of context. So for the first question where we're just simplifying, you'll notice that we have x to the exponent 5 multiplied with x to the exponent 2. And so what you're looking at are two powers that have the same base, and the operation between them is multiplication. So if you think back to what you do when you have two powers with the same base and there's multiplication between them, you'll remember that you add the exponents. So this would be the same as writing x to the exponent 7. Okay? So if we look at the next one, it's very similar to part A. The only difference is instead of having a base of x, now we have a base of 2. So we can do the same thing here. We can add the exponents. So this would be like 2 to the exponent 5 plus 2, which is 2 to the exponent 7. Okay. The last one, very similarly, except the exponent in one of them is a variable instead of just a number. So both the bases are the same. There's multiplication between the two bases. And so we can add the exponents like we have always done. So we get a base of 2 and an exponent of x plus 2. Okay, so this is kind of neat because what it shows is that when you have addition in your exponent, you can actually rewrite it as multiplication with two bases, where one of the exponents, or the first exponent is applied to the first base and the second exponent is applied to the second base. So we are going to see some examples where we might need to break this up into the two parts. Okay. Okay, example 2 looks at factoring. So we have 2 to the exponent x multiplied with 2 to the exponent 2 minus 2 to the exponent x. Now because we're asked to factor, I'm not actually going to combine the bases here in the first term. What I'm actually going to look for is a common factor between the first term and the second term. Okay, and what I notice is that they both have a common factor of 2 to the exponent x. Now if I factor out 2 to the exponent x from the first term, what I'd be left with is 2 to the exponent 2 minus, if I factor out 2 to the exponent x from the second term, 2 to the exponent x divided by 2 to the exponent x gives me a result of 1. And if I look inside the brackets, I can actually simplify this part, and I get 2 to the exponent x multiplied by 2 to the exponent 2, which is 4, minus 1. And so this is 2 to the exponent of x, multiplied by 3. Okay, so there's another way of writing the same thing as what we had before. Okay, for the next one we have x log of 4 minus 2x log of 3. And what you'll notice in this case is they both have a log in each term, but the logarithm is actually not common to both the terms. The first term has a log of 4, the second term has a log of 3. Unless the answer part in the logarithm is the same for both of them, that's not a common factor. So I know I can't factor out the logarithm part. If I look at the coefficients of the logarithms, I have a coefficient of x in the first one, and I have a coefficient of 2x in the second one. And so what's common between these two terms is a coefficient of x. So I can factor out x, and I'd be left with log of 4 from the first term, minus 2x divided by 2 is just 2, and then log of 3 from the second term. And I don't want to actually simplify this further, I just want to be able to factor it. In the first one, I just wanted to show you that you can actually work with this a little bit further, okay, without using a calculator. Okay, so the first example for solving exponential equations is just to remind you of how we looked at solving exponential equations from before. And so one of the things we tried to do is write both sides of the equation using the same base, and then set the exponents equal to each other. Unfortunately, in this case, I can't do that because there's no way I can write 400 with a base of 7. So instead what I'm going to do is take the common logarithm of both sides. And so I get log of 7 to the exponent x equals log of 400. And so because the variable I'm looking for is in the exponent, I can use the power law of logarithms to bring the x as a coefficient of the logarithm. And I get x log of 7 equals log of 400. And then to isolate the x, I know the operation between the x and the logarithm is multiplication. And the opposite of multiplication is division. So I'll divide both sides by log of 7. And I get x is equal to log of 400 divided by the log of 7. So this is the exact answer for the logarithm. Now if I wanted to approximate this, because the log in the numerator and the denominator are both common logarithms with a base of 10, I can actually use my calculator. So 400, log of 400 divided by the log of 7 gives me an answer of about 3.08. So x is approximately equal to 3.08. So this is the approximate answer. Okay, so you can find the exact answer and the approximate answer. Okay, and so if I wanted to check my work, I can just check on the calculator to see if 7 to the exponent, 3.08, so 7 to the exponent, 3.08, gives me an answer of roughly 400. Since I rounded off my answer, I know that my answer, when I actually check it, will not be exactly the same, but it'll be pretty close.